at a given point. Let us suppose x is equal to a, where a belongs to any real number. So now, we know that the function is continuous, so we know in the limit what is left hand limit and right hand limit. We have already discussed in my limit lecture. If you will go to the mathematicsrose channel, and you will subscribe also, and go to my first lecture, in first two lecture in which I am discussing about limit, 2 or 3 lectures in which I have discussed related to the limit, right hand limit, left hand limit, and how when the limit of the limit exists, when the right hand limit is equal to left hand limit. Now, continuous function or continuity of a function is related to the limit of the function. So now suppose that f(x) is any function. f(x) is a function of the variable x, and x has a lot of values, and f(x) is continuous at x is equal to a. Here we are going to explain continuity of a function at a particular point. After that, I will explain continuity of a function in an interval at the point a. Then, if f(x) satisfy the condition limit x tends to a minus f(x), which you know that it is left hand limit, and it is equal to limit x tends to a plus f(x). So when the limit, it is right hand limit, if the right hand limit and the left hand limit are equal, and it is both are equal to the value of the function at the point, this is the value of the function, the f(x) at x is equal to a, then we say that the function is continuous at the point x is equal to a. If the function is not continuous at the particular point x is equal to a, we say that the function is discontinuous. So here x is equal to a is the point of continuity. If this condition does not satisfy or hold goods, does not satisfy, then we say that f(x) is discontinuous function at x is equal to a, and x is equal to a is called point of discontinuity. As you know that, this is just I am writing the definition. As you know that the continuous means flow, a type of flow there is no break. So if the river, if water is flowing in the river regularly without any obstacle, without any obstacle, it means that so flow of water is continuous. अगर वाटर फ्लो कर रहा है रिवर में और किसी तरह का कोई ऑब्स्ट्रकल नहीं है तो फ्लो जो होगा वो कंटिन्यूस फ्लो होगा. In our daily life it is used. And next example I am taking, the time is passing continuously and I am becoming old day by day. Every day I am becoming old. Now, so time is also running continuously. So there is a continuous flow. There is no break. So in daily life, we are using continuous word, which is also called in Hindi lagatar. There is no break. So if in mathematics, fx, suppose fx is the function of x, and if we take fx is equal to, suppose fx is equal to x square plus 1. So if we will draw the graph of this, so let us suppose y is equal to fx and fx is equal to x square plus 1. So this is a quadratic function because x to the power 2, and it is a quadratic polynomial. So now here we will just draw a graph by taking some values. So x and y means fx. See, if we will take over here x value 0, then the value here f0 or y is equal to 0 square plus 1, so it is 1. If we'll take 1, so 1 square plus 1, so 2. If you will take minus 1 square plus means 1 plus 1, then again 2. If we will take 2 square plus 1, it is 5. And if we will take minus 2 in fraction we can also take, but I'm just taking so that we have to only make the graph. Minus 2 square, it is 4 plus 1, then it is 5. So let us draw a graph by taking 2 or 3 points. Suppose 0. In y-axis we will represent y or fx. Y is equal to fx, the function, and the function is what? X square plus 1. And in x-axis we will represent x, means the domain of the function. So suppose this is 1, here is 2, and here 3 I am taking also, and then minus 1, minus 2, minus 3, and so on. So here is 1, 2, 3, 4, and then 5 will come in this. So here is minus 1, minus 2, minus 3. So now here is always positive is coming. So now when x is 0, y is 1. So vertex of this graph is actually, it will be a parabola, because you have studied in class 10th that every quadratic equation represents a parabola. So this point, x is equal to 1, then it is 2. X is equal to minus 1, then it is also 2. So this point, and if we will take x is equal to 2, then y is equal to 5. So then here we have to go, and x is equal to minus 2, then y is equal, then y or f x is equal to 5. So here we have to go. So if we will join this points, so without lifting our tip of the pen or pencil, we can draw this graph y is equal to x square plus 1. So a function fx fx is equal to x square plus 1. Here we can draw this parabola or this curve by just without lifting our pencil or pen. So it is continuous. If there is a break, then it will not be continuous. So next I am coming to draw the another function. So it is continuous. So this quadratic function is continuous. So now we are coming to the next example to explain more about the graph, so that you will understand where the function will be continuous and where the function will be discontinuous. So now we are coming to the next graph and next function. Now see here,